Hello everyone, and welcome back to the Kohi Game Engine series. Today we're going to pick up where we left off in the last video, which was video 77, in getting our render views to be more configurable. And so this video is actually going to be what I'm going to call episode 77.5. This is going to be just basically part 2 of the previous video. So that one was getting a little bit long, so I figured we kind of reached a good stopping point in finishing up the back end here to be able to split that. So we've got ahead and done that, and now we are going to pick up where we left off. So I think probably the next thing that we need to do is go ahead and jump into some of the other renderer changes to get a lot of these back-end changes hooked up, and get those things transferred over to sort of the application and get some of the other pending changes that I have in mind ready to go. So before we do anything else, let's go to renderer backend C and hook up the function pointers for the functions that we added last time. So last time we added some functions here to the Vulkan renderer, and that was viewport set, reset, scissor set, and reset. So we're just going to hook up those function pointers there. And then we also added some function pointers for reading texture data and reading texture pixel. And so those were right after the texture, texture write data, which is here. So we'll go ahead and hook those things up there. We removed the render pass get by name, so we don't have that anymore. We'll get rid of that. And then we added one more thing to get the window attachment count, which we are going to put right after the index get. So we'll go ahead and hook that up. Okay. So the next thing I think that makes sense to do is we'll go ahead and make the changes to the renderer front end that are needed to support all the back end changes that we've made. So let's go over to the renderer front end H file, and we'll start there. And basically this is going to first off involve creating our pass-through methods. So we have our, where is our draw frame? Okay, so right after that is where we're going to allow the viewport and scissor methods to live. So we're going to add those. And then we have our texture methods, which are going to go after write data. So right here. So that's our texture read data and texture read pixel. A little bit further down, we have our render pass get, which no longer exists. So we'll go ahead and remove that. And we'll need to make some small changes to the signatures of a couple functions here. So we have our render target to create, and again, because this is no longer a texture pointer array, it's an array of render target attachments. So we can get rid of this text here that says it's texture pointers as well. And then we need to go ahead and add a few more things to the front end to allow us to get some information from the back end. So let's see. So we have our window attachment get, which was not exposed before, right? Because we were kind of doing that inside the render, but now that needs to be exposed outside the renderer. So we have a exposure method for that. Also the depth attachment get, which was not exposed before either. And that also now takes an index. And then we have the attachment index get and the attachment count get. So we have that. And then our render pass create also needs to take in our new configuration type as opposed to all of these other properties. So we'll go ahead and update that signature. And then we'll go here to the comments and we'll get rid of all of these guys, put in another line here and add our config. And that is basically all that we need to do, at least on the H file for the front end. Okay. So the next thing is going to be doing all of the hookup work on the behind the scenes in the renderer front end. So we have renderer front end, and obviously we have a lot of errors here because of all the things we've changed. So first thing that we're going to do is actually all the way at the top of this file in our render system state, we need to remove some things. So we're no longer going to be storing the IDs for any of these shaders because those are going to be managed elsewhere. So we're going to remove those. And then we are not going to be storing pointers to the render passes either, right? We had a configure to do here, configurable via views. That's what we're doing now. So we're going to go ahead and get rid of those. And we're going to go ahead and get rid of this critical init because the stuff that uses it for the most part right now, we're not going to have anymore. So I'm just going to get rid of it. Regenerate render targets is now no longer going to be the responsibility of the renderer front end. So we're going to get rid of that as well. And then we're going to come here into our initialize, and we're going to nuke a bunch more code. So our renderer backend config, if you recall, now only takes basically the application name. So we're going to nuke everything else. All these past configs and whatnot. These are all actually going to wind up getting moved. But I find it a lot easier to just go ahead and remove these things outright, as opposed to try and fit them in otherwise, okay? So we will go ahead and reset those up on the other side. So we have our critical init here for initializing the back end. We are actually going to completely remove this too because that's actually going to be changing. And so, in fact, let's see. Yeah, let's go ahead and remove it. I'll go ahead and sort of paste in a new version of that. So this is where we're creating all of our render pass objects, setting up our render passes, and then we're loading up our built-in shaders, which we're actually no longer going to do here either because it shouldn't really be up to the front end to determine that, at least not for these, because the views are actually going to own and maintain the shaders as well. Because I think that just makes more sense to sort of group those along with the render passes and all that stuff in the view. So we're actually going to come all the way down to here and nuke that entire section. And then all we have left here is just to initialize the back end. And that is going to change to a if check to say if this returns false, right? So we pass all the same parameters as we had before. We're just putting it explicitly in an if check now, and then writing out our error explicitly and returning false, otherwise returning true. Okay, so we're just cleaning that up a little bit to make it a little bit easier to digest what is actually going on. Okay, so render targets being destroyed is not something that the front end has to worry about anymore, so that is going to be gone. So the next thing that we're going to have to do is we will go into the renderer draw frame, and we need to make a small modification here. So right around when we're doing the window resize, right after we've done the frame sense resize and all that, we have the call to backend resized. What we're going to do is we are going to notify the views of the resize. We don't necessarily have to do it this way, but this is the way I'm electing to do it for right now. So we're going to tell the renderer view system that a resize has occurred and the width and height. All right. From there, we need to implement some of the new methods that we added to the front end. So I'm actually going to come here right before renderer texture create and go ahead and implement the pass-throughs for the viewport set and reset, scissors set and reset. So those are added. A little bit further down, right before the texture resize, we are going to add our read data and read pixel. Again, those are just pass-throughs to the back end, so nothing crazy there. We have our render pass get. That is going to go bye-bye because it doesn't exist on the back end, nor the front end now. So we're not going to be doing that anymore. The next thing is the render target create. So that's going to be down here. Let's see, right here. So right now this is taking a an array of pointers to textures. We need to change that to an array of render target attachments. And that should be all we need to do for that one. This should already be updated to take that, right? So we're good there. And then we have a render target destroy, which we actually need to add some additional logic to. So after we tell the backend, hey, destroy yourself, if we are freeing the internal memory, we actually need to go ahead and zero the memory of the target, right? And that is just to basically clear all of the properties of the render target itself, right? So if we're saying we're going to free the internal memory and everything's been destroyed out of here anyways, there's really no reason not to do this. It'll make it super clear that it's been destroyed. Okay, so next we have, I'm going to put this probably, let's put it right here. We have the render window attachment get at the index, so that's just a pass through, so nothing too crazy there. And then we also will have our other ones. So we have our depth attachment get, our window attachment index get, and our window attachment count get. Those are all pass-throughs to the back end, so not really much to explain there. And then our render pass create is actually going to be a little bit more robust, sort of on the front end. And so obviously the first thing that we're going to need to do is change the signature of the function. So we'll change the parameters here. The return type is B8 now. And before we call any of this, we are going to do some sanity checking first. So we're first going to check to see that we have config and that we have a render target count that is non-zero, because it makes no sense to have a render pass with no render targets. And then what we're going to do is we are going to copy over some of the information for from the configuration to the actual render pass itself. So this is all agnostic of what backend is being used. So we're going to copy, the render target account, the render target count rather, create the or allocate the space for the targets array, and then the clear flags, clear color, render area, and then copy over the configuration for each target, right? So these are all things that could be handled on the front end. And then the back end is basically just going to be config, render pass, and that's it. Okay. So that is that. Then we can come down here to where our private functions are. We have this regenerate render targets. The renderer is not going to be responsible for that anymore, so that's going bye-bye. And that is basically all the changes that need to be made on the front end. So we'll go ahead and save that, and looks like we have an error here. What is this bleating about? Incompatible. Did I forget to change this on the H file? Render pass create. Yeah, that should be a B8. And that also means this should return, because this should also be a B8. This should return that. Okay. So now that should be done and dusted. What is bleating about here? Okay, that's the IntelliSense tripping out, so I'm not going to worry about that. Okay. So that is the renderer front end. Nothing too crazy, right? Okay. So, the next thing that I want to add is, there are a couple of things that we need to add to support some of this functionality that we're going to need. And I guess I can go ahead and add them now. So we need some way, and we've kind of referenced this a little bit in the last video, we need some way to uniquely identify things in the system. So there are two ways that we can do that. There is a unique integer identifier, just a U32 identifier that we're going to use. And then there's also a UUID, which is a basically a unique identifier that's a string that's made up of a sequence of alphanumeric characters and dashes, right? You guys have probably seen these things before. And so we're going to use a combination of both depending on what we're actually dealing with. And so we're not going to use them necessarily in depth both right away, but I want to get them in now because we are going to need them very soon. So I think it makes the most sense to go ahead and add the numeric one first. So under core, I'm going to add a new file, and this is going to be called identifier.h. All right. And this is going to be a very, very simple interface. Okay. And basically all this is going to do is say acquire a new ID or release an ID. And that's going to give us a unique integer identifier. We're going to pass the address of some owner of it. And the way that this is going to work is internally there's going to be a lookup table to say, hey, does this particular identifier have an owner? If it does, then it's considered taken. If it does not, and it's basically 0 or a null pointer, then it's not owned and it's available. And so that is what we're going to implement now. So I'm going to go to new file again, identifier.c, and I'm just going to drop in the code because I've already pretty much explained it. So it's actually pretty self-evident as to what's going on here. So this is the acquire ID. Basically, we have this static pointer of void pointers. And if that doesn't exist, then it goes ahead and creates it. For now, I've set this up to be 100. This obviously needs to be larger. In fact, let me just... Yeah, let me just bump this up now. So I'm going to say 1024, right? And that still needs to be larger, but at least we won't hit that right away. So basically, this is a system that sort of runs on its own. That doesn't really have any configuration. We could make this configurable and make it sort of dynamically expand. I guess, actually, you know what? 100 is fine. Because we're using a D array here, it's going to dynamically expand if it needs to. So we're going to start off reserving enough space for 100 of them, and that will basically keep a bunch of resizes from happening early on. So we're going to push an invalid ID as the first owner to keep index 0 from ever being used. So this will tell us index 0 basically will be an invalid ID, right? So we don't want to use that one. So basically what this does, after it's confirmed to be set up, it loops through, tries to find something where the address is 0, and that says, okay, well, set that, and then return I, right? And that's all it is. And then releasing is just going to that index and making sure that it's already set to something, but then setting it to 0, okay? And that's it for that, okay? So it's actually pretty straightforward. It's probably not as robust as you might have been thinking it would be, but it's going to be reliable in making sure that those identifiers are unique and not repeated. So the second type is going to be UUID, and that interface is also very straightforward. So basically, this is going to be a structure that's going to hold a character string that is 37 digits long. And that's going to account for the format of a UUID, including the dashes. And this will give us a unique string. And there's going to be basically 2 iterations of this. So our first UUID is not going to really guarantee much at all because it's a very simple solution. And so I'll show you what I mean create the C file. So I have here this quick and dirty flag, and this is basically a substitute for a full implementation that doesn't exist. This does not guarantee any sort of uniqueness, as it's just using random numbers, right? There's nothing unique about this, no sort of guarantee that it's going to be unique. And so with that, this is a very simple algorithm that we're using just to generate something in the format of a UUID, which I'm initially just going to use for a texture name. So it doesn't really matter all that much. But eventually we are going to come back and implement a proper UUID. But I wanted to get something in here so at least we have an interface or something to sort of get up and running with. Okay, so that's as far as I'm going to go into that for right now. There's also something I want to add to KMath. And this is going to be added to the header file. And I'm going to put this all the way, I think, at the bottom of the file. And we are going to have a few utility methods in here right after our conversion methods. So we're going to need some methods to basically convert various ranges of F32s. And so basically what we're going to take is a value to be converted, an old minimum and an old maximum, and a new minimum and a new maximum. And it's basically going to use a ratio to essentially convert it from one range to the other. So for example, if you wanted to create, if you wanted to convert from a range of 0 to 1 to a range of 0 to 255, this would be the method you would use to do that, and it would give you the equivalent. The next thing is we have an RGBU to U32. And what this does is it takes RGB values, pixel values, 0 to 255, and packs them into a single integer, right? Just by doing bit shifts. We could have an RGBA version of this as well, but for right now I'm just doing the RGB version. And so likewise, we also have a version that undoes that, where it takes a packed integer and unpacks it. Then we also have a RGBU to vector 3. So it takes the 0 to 255 values and converts them, and then passes them to a vector 3, which will then be in 0 to 1 range. So that conversion is automatic here. And then the opposite of that, which takes a vector 3 and unpacks those values and converts them to 0 to 255 range. So in here, these two are making assumptions about those ranges, but that's just to sort of speed things up. If we want something for a different range to be converted, we can use this guy. Okay. So we're going to need that. Again, not right away, but we are going to need it. All right. So the next thing that we need to do is we need to probably go into our shader loader and modify a couple of things. So let's go shader loader. And where we're actually loading up the render pass name, we are actually just going to ignore this now. And we should probably also warn against this at some point, if that's actually left in a particular shader configuration, but for now I'm just going to ignore it. So let's see. So we need to add our new values here for depth test and depth right. And I think I'm going to do it right here. So basically all that is we're basically going to be parsing a string. So we parse depth test, and then we're going to say string to bool, and save that in the depth test, and then we're going to do the same for depth right. So string to bool, if you don't recall, we'll take the value 1 or lowercase or uppercase, case insensitive rather, true. So if you say 1 or true, it will return true. Otherwise, it will return false. So we're just going to do that to read that in. And then all the way down here at the bottom, we have this render pass name here that's being freed. That doesn't exist anymore, so we can kill it. All right, so that is that. Let's go ahead and let's make another minor change to UI text.c. So we are actually going to use our new identifier. So right after kstring, we're going to include core identifier. And we're going to fix the errors in this file too. So we are using this built-in shader name UID. That is just going to get replaced with the string itself for the shader name, which is fine. And then we are going to, right after we generate our geometry, we are going to get a unique ID. We need to add that unique ID, so we'll come back to that in a second. When we go into destroy, let's see. First thing we're going to do is release the ID. Again, we don't have the unique ID, so we'll have to go ahead and add that here in a second. And then also when we're releasing the shader resources, we need to go ahead and put the name of the shader there. So that's all that's required there. And then for the unique ID, we need to go to UI text H, and we need to simply add to the UI text struct unique ID, and that will fix that. Excuse me. Okay. So the next thing is we need to make a minor change to our material system because we broke something in there. So remember, we got rid of the shader name material and shader name UI. So we just need to add the hard-coded strings for that, which is fine because these are built-in shaders and this system should know about them. So we'll go ahead and do that. And then I'm actually going to need this one more time. Let's see. So this is going to be in create default material. Next one right here. That's the last one. Okay, so that is that. And now we're actually going to go into the render view system. And we're going to make a couple of modifications here to support the changes that we have made. In fact, let's go to the H file first. View system H. So the first thing we actually need to do is add a new function here to regenerate the render targets. We're calling that, if you recall, we added that call from the render front end. And then we'll go back to the C file here, and we will add and change around a few things here. So right around when we're creating a view, when we're setting up the view passes, this is now just an array of render passes, not an array of pointers to render passes. So we're going to k-allocate the size of a render pass, not a render pass pointer. And then what we're going to do here is we are just going to go ahead and create the render passes according to the configuration that we pass in. And so what we're actually going to do is I'm going to eliminate this code and just sort of put in a new version of it, which is basically going to be this. So we're going to say render pass create, the address of render pass sub I, the address of view passes I. If it fails, bleat about it and return false. Next, in our little sort of pseudo switch here, we are going to say that the view regenerate attachment target is going to be 0 because this view doesn't need to use that. And in fact, none of the views that we have so far need to use it. The view that we're going to be creating very soon is going to need it though. So we want to go ahead and zero that out just so that that is ready for the next iteration of updates here. The next thing that we'll do is we will make a call to render system regenerate render targets for the view that we just created. And then we'll obviously need to implement that function. So I'm going to go down here to the bottom and paste it in. This is basically what was in regenerate render targets in the front end. So it loops through the render pass count, gets that, takes a look at each of the render targets within that. So it takes a look at that, destroys it if it is already created, otherwise it does nothing. And then loops through the attachments themselves. Based on the source, the type, it goes ahead and gets the appropriate texture, so whether that's a window attachment or depth, or bleats about it if it's invalid, or if the attachment source is the view itself, then in this case, it will actually say if the regenerate attachment target is not set, which we set to zeros on all these guys, right? Because none of these have it. Then we're going to actually treat that as a fatal error because we're going to say, hey, we're saying that the render, that the view should be generating render target attachments, but it's not set up to do so. Otherwise, if it is set up, then it just checks to make sure that's successful, and if not, it goes ahead and returns an error and then keeps moving on. Once it's done with that, then it calls the renderer render target create, passing through all of that data. One thing to note here is I'm just going off the first attachment size here because the first, if it has multiple attachments, more than likely those attachments are all going to be the same size. So it's a pretty safe assumption to make. Okay, so that is the updates to the render view system. So nothing too terribly complex, but yeah, it's just another thing we had to sort of knock out. Next, we need to go to shader system.h because we are missing some information here. So right below the shader attributes, we are going to be putting in a couple more type defs. So we are going to have our shader flags that we had before. So we have none, we have a depth test and a depth right. So those are just our new shader flags that we're reading in from config. And then we're also going to have just a type def for shader flag bits, which is just a U32 just for convenience. And then on the shader itself, right below the name, we are going to have those shader flag bits. Okay. And then the shader system create is going to receive a small update. So whenever we create a shader, we are going to provide the render pass at that point. So go ahead and add a comment here to that effect. All right. So we have our render pass being added there. All right. So that is the change for the H file there. That means that obviously we need to go to shader system C, and the shader system create here needs an update as well. So that render pass is going to be provided here. And then basically what we're going to do is instead of calling render pass get, which doesn't exist anymore, we're going to get rid of that. We're actually going to get rid of this whole thing here because we're not getting it that way anymore. Instead, we're actually going to replace that with some processing of flags. So we're going to check to see if depth test is set, and then set the flag, set the depth right flag if depth right is set, and then go ahead and pass that on to shader create. And because this is already part of the shader struct, we don't actually have to change this signature. So that's the only update we need to make there. Texture system is another thing that needs to be updated. So this is basically just one single update. We've referenced this a couple times in the back end. We just need to make the change here. So we have our wrap internal. To that end, we are going to add a pointer to the out texture. We're going to change the return type to void. And then obviously we'll go ahead and add this and then get rid of the return. All right. And that means that obviously we need to go ahead and make this change in the C file as well. So texture system.c, wrap internal, go here to the end, add that, change this to void. All right. And really the only change is going to be we are going to get rid of the allocate here. So this is if we're not registering the texture, right? So in fact, instead of getting rid of that, what we're actually going to do is we're going to wrap it in a check. So we're going to first say if the out texture has been provided, then we're going to set T to the out texture. Otherwise, we allocate a new one. Okay. And then we'll go ahead and move that up, that K-trace, just in case we want that. And that is the update for the texture system. So nothing too crazy there. Okay, so the next thing that we need to do is we need to update our, I guess it's time to go ahead and update the views. So let's go ahead and do that. We'll start with view skybox. I think the only thing we actually have to change for these are the C files, thankfully. So there's not a crazy amount of changes that we have to make to this. So starting at the top, we are going to add the resource system as well as the render view system. So we'll put that right there. And then instead of holding the shader ID, we are going to hold shader pointer S. It makes sense to just hold on to that reference instead of having to look it up all the time. We are going to add an event handler. So right after the internal data structure, we are going to add render view on event. We are going to subscribe to this render target refresh required, and then call render view system regenerate render targets on ourself. And then we're going to come into on create, and we're going to basically refactor sort of this section. So instead of getting the shader from the shader system, because we wouldn't have actually created it yet, we're going to go ahead and set up the shader in here, and then go ahead and load the resource and all that, and set up the all of these locations as we need. So basically, this is what we're looking at. So we have the shader name. We load the resource. We create the shader here. We unload the resource, and then we go ahead and get a pointer to the shader, set up the locations, and then continue as normal. All right. So this now owns that shader, okay? Because it's the only thing that uses it, so it doesn't really make any sense to do otherwise. Okay. So a little bit further down, after we go ahead and grab the world camera, we are going to register for the event, the refresh required event, just passing that to the function that we just created up there. And naturally, that means that in the destroy, we are going to go ahead and unsubscribe from that. And then we should be good to go. The only thing that I want to note in here is we don't need to destroy the shader, because it is automatically destroyed by the shader system on shutdown. So even though we've gone ahead and loaded it here, we don't need to destroy it. Okay, so the on resize, basically these aren't pointers anymore. So they just need to be converted to dots. And then the onRender just needs a small change. So instead of shader ID, we're going to say data s.id, or arrow ID rather. And this render pass here is just going to be the addresses of self passes sub p. And that is all the changes that we need to make for the skybox to support everything that we've done so far. Not a crazy amount of changes. And the other changes to the other views are going to look remarkably similar. So render view UI is going to be much the same. So we have our resource system. We have our render view system right there. We are going to go ahead and get rid of the shader and just call it shader S. We have our render view on event right there. And then we have a number of changes to the onCreate itself. So the first thing that we're going to do is go ahead and load up the resource and create the shader. And then this is going to be data S, get shader. In fact, I'm actually just going to drop in this whole new section because it'd be quicker. So we're going to go ahead and get the shader, get the locations, and so forth. And just like we did before, right before we return true, we're going to go ahead and register for the event. And then, of course, since we are registering for the event on destroy, we need to unregister for the event, right? And then on the resize, these arrows become dots. And then a little bit further down, we have, this should be S ID. And then we want the address of self passes sub p. And that is all the updates for that. And then real quickly, we'll do the world view as well, which is also going to be pretty similar in terms of what updates are made. So we have the resource system and the render view system. Instead of the shader ID, we have shader S. Now, in this case, we actually already have an on event, so we're just going to add a case here to handle that. And then in the onCreate, we are going to go ahead and get rid of this. Let's see. In fact, actually, instead of doing that, let me just add this here, okay? And then this getting of this will actually just be replaced by that. And then we go ahead and get the locations as normal. We want to go ahead and register for the event. We already registered for an event here, but we need to register for the refresh required event, which means we also need to unregister from that in the destroy. So we'll add that, right? These all need to become dots. All right, and then a little bit further down, this is S ID, whoops, S ID, and the address of self passes sub p. All right, and that is the views converted to the new format. All right, I think we're nearly there. So I think the fastest way to get through the application changes is probably going to be for me to just go ahead and drop in the contents of the file. So We will review the diff on this just because it's going to make it a lot easier to understand all the changes, because as you can see here, there's a lot. So what we're going to do is go here and application, right? And I'm just going to close that. And we'll start at the top. So we've added our identifier and our UUID. We have our hovered object ID, which is something that we're storing for the currently hovered object. We're not actually using that yet, but again, hint, hint, next video. So we're going ahead and calling our UUID seed here. We obviously should be using something better than a hard-coded seed, like something based off of date time or something like that, for better randomization, but for now, this will work. We are registering for the hover ID changed event that we'll be handling here shortly. We have taken the material system and the geometry system. We've actually moved those further down the list, so I'll show you that in a second. And here is where we're actually putting our configuration for our views. Now, this is only temporary because really the consuming application is what should actually be providing this configuration. So one of the things that we need to do here very soon is we need to get a lot of the loading of assets, even the testbed assets, the fonts, the configurations, all that stuff. We need to take all that out of this application and move it to the actual consuming testbed or editor or whatever it is we're going to be using. But for right now, I'm going to put it here because that's where all of it else is otherwise, and then we'll just move it from there. So these render review configurations are a bit probably what you would expect. It's somewhat similar to what we had previously in the back end / front end. It's just kind of all in one place now. So what we do is we declare a view config. We give it a name. We say what its view matrix source is, how many render passes we have. We set up an array for that. We give the render pass a name. We set up the render pass render area, clear color, clear flag, step, stencil, all that for each pass. In this case, we only have one. We set up our attachments, right? So we have a single attachment here, which is just a color attachment. This is for our skybox, so that's all we need. We don't have depth. And then we set up our target attachments. In this case, it's just a single one, so we just use the address of that to treat it as an array. And we have an attachment count of 1. And then we have the target count, which is going to be the window attachment count. And then we go ahead and we create the view, and it takes all that configuration and runs with it. The world view is pretty much a very similar thing. Now we've renamed the configuration here from world opaque to just world because it handles both opaque and transparent. So that was a little bit obsolete. I suppose we could rename this as well. Let's just call this world config, world view config, right? And that's going to make the change a lot worse, but I think it makes more sense. So we have the render view config for that. So we give it a name. That should be gone. And then we set up the render pass for that. Again, we only have one pass, so we set that up. We have our attachments. In this case, we have 2. We have our color attachment and then our depth attachment. So this is where that's configured. With our load operation, our store operation, our present afters are still false. And then we set up our attachment count, pass through our array, get our target account, and then go ahead and set up the passes. And then we go ahead and create the view system, or the view for that, okay? Finally, we have our UI view. So again, our render pass config, we have one render pass. We set that render pass up. We have one attachment, which is a color attachment. In this case, present after is true because this is the last one in line. We're going to be presenting once this render pass completes. So we need to attach or set the color attachments present after to true. And then we go ahead and say we have one attachment. And here is our attachment, and then here is the attachment count. That is basically the swap chain image count. And then we go ahead and create that. Here is our material system and geometry system creation. These have to be created here because they rely on a shader, the material shader that is created by this guy. So this is a dependency that I'm looking to eventually reverse, but for right now, it is something that we have in place, so I did have to move these. The next thing that we do is we are moving the debug text that we have to the bottom of the screen. So we're accomplishing that by taking the height of the screen, subtracting 75 from it, and using that as the Y. And then we set the UI text position. We just move that over, or move it down a little bit. We got rid of the constant here, so we've replaced that with the hard-coded string there. We set up a unique ID on all the meshes. So Cube Mesh has one, Cube Mesh 2 has one, and 3. The Car Mesh, the Sponza Mesh, they all are getting unique IDs. The UI Mesh that we have, that's the little Kohi logo up at the corner, that also has its own unique ID. We're also going to start tracking some frames per second here. So that we can actually log that to the screen as well. So this means that we're taking an average every 30 frames. And this eventually is going to be moving to something a little bit more robust than this, but for now I'm just putting it in the application. So we have a whole bunch of things here to accumulate millisecond averages, milliseconds, and frame counts to be able to calculate that frames per second. We go ahead and we build the render packet. The only thing that's changed here is just the name. And then we're also going to go ahead and track our current mouse state. We're going to get the screen coordinates of that, the NDC coordinates, which is that 0 to 1. And then we're going to calculate the frame average whenever that is exceeded the average, so every 30 frames or so. We're going to re-report that average. And then we're going to, a little bit further down, we're going to print all that information. So this is all adding information to that debug text to make it a little bit more useful, give us a little bit more useful feedback as we're sort of interacting with the application. We do have this hovered object ID, and again, we are not doing anything with that yet. So for right now, you can just ignore that, and I'll explain it in the video when we actually get to that. We go ahead and we update the frame elapsed time. That is to get the running number of milliseconds when we work out that frames per second calculation, and also a frame counter to help with that calculation. And then further down, we have our event handler for the ID changed, and that just sets that state hovered object ID to that context. Again, nothing's going to happen there for right now until we actually get to that, but that's just a hint of what is to come. And then what we're going to do is on the resize event, we are going to temporarily set the UI text position for the debug text to the bottom of the screen. So we're basically going to make that stick to the bottom of the screen by just changing its coordinates anytime we resize. So with that, we should be able to clean and build. And looks like I have one error. Let's see, what is this bleating about? Render target create. That's supposed to be a B8, so I missed that. Still one issue. I forgot to change it at the interface level too. B8. Build. Right, I don't think we can actually fail this, but I wanted the ability to report it if we do. Okay. Render pass name, oh, that doesn't exist anymore. Texture system. Return T, oh, this shouldn't be a return T. This should be out texture. Out texture equals T. Or no, actually we don't need to do that at all, actually. Because T already would have been set. It's already a pointer to something, so actually we don't need that line at all. Oh, that's a return 0. That shouldn't be doing that anymore because it doesn't return anything. Okay, so now we're good. All right, so let's go ahead and run. And there we are. So we've basically refactored our view system to be a lot more flexible and to be able to provide us with the ability to implement the feature that we are going to be putting in next, which, if you haven't guessed by now, is object picking via hovering on the screen. So we're going to implement the ability to basically hover over anything, whether it's UI or an object in the scene, and we are going to be able to have pixel perfect basically mouse picking of that. And we're basically going to initially set it up so that it is done constantly, but eventually we're going to be able to utilize that for many, many things, various editor functions, UI, interactivity, things like that. But for right now, what we have here is we have a running FPS, which I'm running at 75 right now, which is my refresh rate on my monitor. So it's synced to that. We have our position, which we've had before. We have our rotation, so that's still the same. That all works. We have the mouse X and Y, so we can see here that's 0, 0 when I go all the way up there, if I can get it. And then your 1280 by 720 down here. You also see that this NDC here is 0 to 1 range, so it's 1, 1 down there, 0, 0 up here, right? More or less, if I can get it. There we go. And then, well, actually, no, it's not 0, 0, my bad. It's -1. So -1 to 1, right? And then we have the this L and R is basically whether the left or right button is down. So if I press and hold the left button, we see that that's changed to a Y. When I release it, it goes back to N. Same with the right button, right? And I can do both at the same time or change them back and forth, right? It just updates as fast as I can click. And then we have the hovered, which is basically going to return to us the ID of whatever is currently hovered over if it has a unique ID. And we're going to use that unique ID to not only identify objects and be able to pick them in the scene, but also to go ahead and use that when actually picking to actually be able to pick the object out of the scene. So we're going to cover that in the next video, or maybe the next couple of videos. I'm not sure if it's all going to fit into one, so we'll see. Anyways, this has gone on for almost an hour now, so I'm going to cut this video here. Thank you guys so much for watching. If you haven't already, consider subscribing. Toss the video a like, thumbs up, leave me a comment if you have any questions or concerns, and I will see you guys next time. That's about it. See ya.